Okay, so get to writing this crazy function. Web camera dinger. Okay. It still wants me to. Oh, it's like, why is it still DirectX? Yeah, it still wants me to use DirectX to do this, or Windows. What is? So I don't want to use this thing. Windows Kit 10 lib. So it's a part of Windows 10 glib. Huh. So I don't need DirectX. Yeah, the component module. Not all the devices will work though. That's what I know from the other computer. You'd have to try this with the stripped down Windows version. I need to install, I think I do have MSys installed. Alright, so here we're gonna have to define a quad. Now we know this Vertex Dynamic runs for 128 gigs. Megabytes, sorry. Same difference. I'm gonna pass in dynamic, number of vertices. Let's set this to 4 for now. We'll make another function called int alloc CPU to GPU block. Just like stick one of these in there. I really don't want to define these for no reason, but they do serve a purpose here. No, it has to be float. Minus 0.9. I don't like 0.9f for whatever reason, because that's the size of my level with things. Okay. This is just like one block. I don't even know why I'm bothering to do this part right here. It's more for reference, which is annoying because it's like junk code just for placement, just so it can compile. Okay, so we only have 4 for now. So I don't want to uncomment this and leave a bunch of garbage everywhere. But am I forced to do so? No. So let's do it like this. Let's get rid of... Do we need to get rid of printf? We sort of do. Let's get rid of that for now. We will need that later. And just let's bring this back to life. So we need first quad. first quad will be this, I guess. I guess it's going to be 6. So we just need to draw a quad. What this will do is we'll call this and put it into GL buffer data. And we'll update it using like rotation or something. So let's do this also. Create this instance. I'll figure this out as we go along, maybe. I only have like another half an hour left, so I need to just like get a few quads on the screen. How to convert X, Y, Z to matrix form in C++. I know it's, I already forgot, sorry. I'm still waking up. That's why I need a little like, it had the other thing in there. It put some kind of, using the NGN library. This NGN library is used by TensorFlow. I know because I've tried to compile it in GCC and I've had like library masochist problems where I had to just sit there and like fix all these libraries. Like I tried to do it this really weird way where I'm converting newer C to like older C and going to all these repositories. Okay, so that's the initial. And usually it's just better to just draw this out. Like, I guess what I usually do is I go and I copy paste stuff that I did. Do it again. Since we're starting a new RTS engine, it'll be like a celebration to do this. Again, and again, and again, probably, for different things. Alright, so we have triangle. This will be 1. This will be 2. And so the order matters. And this thing matters too. It's good to know this, and then also can be able to convert it from engine to yeah, GLM. From engine to GLM. Using no libraries, convert X, Y, Z to a 4x4 matrix. That's our standard kind of data type, is the Beck4 matrix. It said the name of it. Yeah, so. Oh, so 1, 2, and 3. They're all on the 3. I had to just like go and copy a bunch of, or watch a bunch of videos on what's it called? What are they called? Not Udemy, the other one. Khan Academy. Khan Academy has some good videos. They're really ghetto, but they'll get you through it if you try to copy them. Like, that's what I like to. It's like I had to be like force myself, and I forget my password. Damn it! Just make an account real quick. But yeah, we can just go to their YouTube, I guess, for a second here. Khan Academy, because it has the rotation matrix code that we need for games. And it's a good explanation because it's more of the math form of lecture. Algebra. It's called linear algebra. Is really what most video games are. 99% of the source code is linear algebra. All right, matrix. Yeah, like you should have this guy's voice in your head if you're a computer programmer that's starting out, because then you know you're in the right place. So visualizing. Yeah, so he explains things like transpose and the notation. The notation is the most important part. Now his handwriting is like better than mine, but don't let that encourage you or something. Okay, linear transformation. The one I was looking for is R2. So this is visualizing space in R3. Whatever that means. I sometimes know, I sometimes forget, I sometimes get really into it and think it's all stupid. I don't really need to learn in this anymore. And then I come back to it. Okay, so this is the important thing. Because he explains how we're going to rotate a quad. That way I don't have to do this. Because this is going to be important like really soon. Alright, so we're defining point 2, which is y is less now. Just need to get rid of this. We'll just keep recycling these numbers. They just make it easier without plugging them in directly. So when you increment this, you're incrementing pointer. So y changes to, let's make them 30. Make the numbers nice and kind of 5-ish, but also 3-ish. The prime numbers of them. Okay, so that's triangle 2. We'll denote this is 2. Denote this is 1. 1 vertex. And first we just need a quad. So it'll be 6. Because this is like going from those crazy people that try to run their own rendering engine for no reason. Without that, but okay. Now the order of these, it should actually go look up so here we will comment this. This is like good to have this here. Matrix order. Oh, that's the translation matrix? Nice. Transformations. What I needed to do? It's negative 0.75. That's where X is located of this quad. It's kind of like going ahead, but kind of like to keep my sanity straight. All right. Okay, what we need is, this is also good. We need this, and we also need, this is like important or something. Yeah, and how to multiply them. Scale stuff. So you need to scale and rescale. Yeah. Using these ones. Now you can do this with quadraternions too. And it's like important to use quadraternions because these don't always work. It's easier to use GLM, but it's cooler if you make your own graphics library. Like this is a good result because it really shows us 4x4 translated to the center virtually. We use the time times the rotation, and only rotate by z-axis, which we can't see because this is on x and y. Well, we can, but we can't, or something for 2D. That's the fourth axis if it's 3D. I mean, yeah, so let's try and search this. OpenGL triangle winding. And this is the problem with learning OpenGL, is that you kind of set it up and then you have to go back and relearn these two things. And then you have to go and like keep going back and forth and all these things and like still keeping sane with the whole. All right, so 1, 2, and 3. 1, 2, and 3. Counterclockwise. So how is our winding? So what if you start at this side? Start at 9 o'clock. Or I started at over here. So you have 1, 2, 3. Yeah. Oh no. Face culling. Winding, face culling. You have to memorize both terms here. I'm going to comment this as triangle winding order. It's like really important. Because how you're going to do your really cool transparency effects, which you want to do early on, is you're like, oh, I accomplished something with my life, will be, the fuck? It's cool though what he did. I like what he did. A lot of these comments are also really interesting to read. They really get you. All right, so he said, I guess you can't edit posts here too quickly without pissing off spam detector. Anyway, I came here to do exact things. I made my own counterclockwise vertices for the cubes, ground, and windows. Counterclockwise winding. Bottom left. Now note this is 3D. Horizontal plane vertices. Vertical plane vertices. Good catch, wrong link. Exercise instead of kind of going down. Now it's fixed, thank you. So this is the correct. And this is why we put numbers on our cube. So later when we import our model, we can test. And we also going to need a, yeah, so here he's porting from Unity into his own engine. And he's got a little compass. And it's good to have a, I made one of these, a gizmo thing. There's another name for it. But it's also good to make that model from the start, get-go. And probably one of these too, a compass, 2D compass and a 3D gizmo. So you can do like right hand rule without like doing the right hand rule. So I'm confused. Okay, so here it's this way, here it's that way. And what is it when it's... So let's try to wind this counterclockwise. 1, 2, 3. So this will be 4, this will be 5, and this will be 6. Okay, that's what I tried to do. Wind CCW counter clockwiser. Okay. So 1 is the negative. No, the most negative is this one, right? Uh-oh, now we get into convert world chords to 2D plane screen chords. Local space, world space, yeah, and then we're gonna have to set up the camera anyway. I don't want to have a fork comment. That'll be in the camera class. There could be a camera 2D and a 3D simultaneously. So I'll just put this in here. And we want to use orthogonal, I believe. And we could use 2 projections, perspective and orthogonal. That looks so much different. That looks good. I like how it's like stupid. Yeah, like how do you do this with using this? There's like a way to. They kind of try to tell you without telling you. What does it say at the end here? GLM's ratio solution. I saw it somewhere, I think. No. It's just like my eyes lying to me. Happens all the time. Coordinates are stupid. There's too many of them. Yeah, the NDC. Normal, I forget what it stands for. Dimensional crap. It's like important when you're selecting stuff and clicking places. So you have to like just be able to do it like in your head instantaneously once you get used to this. All right, so I'm stupid. I should just be raw coding everything right now. Okay, so 1 starts up there, but I didn't get the coordinate space yet. Like there was no picture. What we really need is a picture like this. So that's -1, 1, because this really references our problem here. That's -1 and 1. So we should have started, damn it. If we're starting at 1, so this will be 1, this will be 2, and this will be 3. Counterclockwise, right? Now, the way they start it, they usually start on the top. Okay. Yeah, but their triangle is different. Why didn't they draw a quad triangle? This is my point. Why don't they just give us example with simple quad? No one ever does. Maybe if we go to Apple Metal, they will. Let's try that for a second. Developer Apple Metal tutorial quad. They're like a little more sophisticated or something. Rendering pipeline to render primitives. Understanding Metal 4 API. I guess they just released Metal 4. Sample code project associated with Discover Metal 4. No. Who cares?
And display and textures to create input tensors.
That's like
Metal Lab already
we're just worried about like a quad. We don't need input tensors. Explore Metal 4 games. No, just give us like the easiest sample ever. This is what I hate. It's like they just dive you right into the snap of it all, and then you're like, I just want the raw basics so I can just start getting a really simple thing to work. You're like learning about USDC format, and you're like, okay. So how are we supposed to convert GLTF to USDC if we can't just get a quad? Process structure and compute function. We just need basic quad. Alright, so they do this quad differently. What they do, you can see in the picture. Oh, now we're not. There's no picture anymore. Yeah, like what this does is it has 4 triangles per quad. So this would be another way to do it, but we're trying to just achieve the simplest quad. Okay. Yeah, so negative, positive. So let's just denote this. Negative, positive. I don't want to put the 0.1, it just adds more clutter. And this will be 1, 1. And this will be 1 negative. That's like important. That's like the most important step. It's so theoretical or something. So negative 1, negative 1? Yeah. So our quad actually starts at negative 1, negative 1, at least from our definition. The definitions could be different. So negative 1, negative 1, okay, it's negative 9, yeah. So 2 should be positive, negative. The x is positive, okay, so this is 6 and this is 9. So number 3, vertex number 3. Number 3 would be negative, positive. Opposite of this. Oh, I can't write. Type. Okay, so that's vertex 3. Let's clone this. Copy paste, I mean. So vertex quattro 4. 1, 1. So that's going to be at 6, 6. Okay. Vertex 5. 5 is x is negative error, and y is positive error. So I did something wrong here. For some reason, I have the x's in front of the y's. That's so stupid. Ugh. I need to fix this. Y is x after y. It confusing me. Okay. Now I have to redo it. Okay, x says vertex C2. X is positive error. Y is negative error. Okay, good. Double check this because I had it reversed. I don't trust it. Okay, x is negative error, y is positive error. Okay, good. X is both positive error. Good. It's annoying. Why is it like this? Yeah, this is where the mistake would come in. Okay, 5. X is positive error, y is negative error. 6. 6 is the unique one. X is positive error, y is negative error. What? What about 4? 4 is right. 5. X is negative error, y is positive error. No. X is negative error. Y is positive error for 5. Okay. Yeah, I was going to screw up 5 no matter what, and I did. Alright, so we have one quad. Then vertices. Then vertex is 6. There's 6 points. We can go and allocate this. Okay. We allocate it, put it in the VBO and the vertex array thinger. The next is going to be abstracting this, adding more of them, and increasing draw count. But we have the system now for dynamically adding them. Not yet though, not completely, because we need to select the shader type and just sit there and discard, or just add the buffer. And be able to increase the buffer size. So, render cache quads, VRAM, we'll call this, because VRAM is cool. And we'll just have to say 6 for now. So there could be a draw index of start and finish. And we could individually. There also is draw lines. Can we do draw lines? It would be nice to different line shader. See what happens without the lines than with the lines. Stupid OpenGL. Thing is stupid. Let's see. Did all my work go into? Okay, it's just the abstraction code that doesn't get used. There is something I don't like about this. It should be over here. It's in the wrong place. Did we really something else. No, we didn't even call this. We called something else. It got text from probably this. Yeah. So what it did is actually this. It it used this part 1 alloc graphics. Did we do that in our thing? No. I think the most important thing to call this. Okay, let's try ours. Or that was my old one, but whatever. No. Uh-oh. What did happen? They wanted to tell us what happened right there. Something bad. I think it's because of the allocation I did. And it's not releasing it or something? I don't know. Well, that's going to be a fun one to fix. But are we entering this? Like, what's going on here? This is terrible. Yeah, okay. So it does this. Oh, here's the problem. It's like passing in like weird trash. Well, it's not weird trash. This is actually defined. So it's passing this in. It's using this quad. What we want is our dynamically allocated structure. It's a static. It's sort of like a smart pointer, I guess, but we're trying to go no smart pointer. We don't know that that exists yet. We're still back in time. We want this to compile in potato and turn a trash can into a NASCAR faster than a Tesla. Since we don't even have electricity, we just have gasoline and stuff. And we're cool. Alright, so 44, we have to insert this. I don't know if size is going to be right though. Let's keep this garbage. Rename this to VRAM. And then later I have to go and like do super cleaning, I guess. And I don't know. I never accomplished that. It seems like impossible. Okay, whatever. Then we could rewrite it for the text and somehow rewrite it for the model. Okay. Sure, we do call this 6. But I believe we need to times this by 4. Go look at the other sample. Because it might not send enough stuff in there. We get blank screen at death. Okay, and it did. We still get this crazy error though, which is bad. I wonder why. Because we're using this thing. Let's say times 4, which is the size of float usually. It could be different. I should put just size of float. Uh-oh. Whatever I did was a good thing. Alright, there's a few more things I have to, I think, address, like the fact of why it's this. Okay, no, I don't want to do this peak thing. It's weird. Okay, so we get this thing. INIT VRAM. Does this allocate? Make sure that's not hitting this. And if it is, we need to exit program. What the hell? So it gave us some crap. It allocated, whatever. The problem is, I should also be setting this to null. Damn it. Oh, that's cool. I'll put this like here. Oh, we need the initial position actually. Crap. I know it's wrong. We need an original. We did it wrong. Okay, so this one is C69050C. Okay, changed C695064. Alright, death. And I know it's wrong. This is what we need. We need another static thing. Now the other thing, I don't know if that's going to disappear. We do this, but I hope it does. That's very bad. It's doing that. So in this one, we have this thing called original. Now original means the original address of the start of the location of the allocation of the memory. It's the 0 offset. It's offset at 0. So that way we keep the pointer around where it started. Okay. Let's go find where we pass it in. This is why we need that other function, I guess. We could just always reference off original and dynamic. It's kind of bad. It's actually better to call one an incrementer instead of dynamic. It's just confusing. Oh, crap. So what would happen if we did this? It's just like, why? Like, it's not going to be able to fix itself after one of these operations. It's going to do something really bad. Yeah, like that wasn't supposed to do that. Uh-oh. I've created a Jack-in-the-Box Frankenstein. I wonder what's wrong. It's definitely a heap allocation problem. Maybe when I call free, that's when it happens. Freeing a memory block twice. That could be what's happening. Yeah, he wants you to use unique pointer, smart pointers. But we don't want to do that. We can manage our memory ourselves. Alright, I know what it is. It's because, or, let's, what we have to do is just swamp original. If we do this. Then, when we do free, we free it at the right place. I think that was the issue. Without having to change the other part of the code. But the thing I'm still worried about is like, why is it not drawing things? Okay, good. We got rid of the heap corruption error. It was really scary. At least it caught that. Sometimes it doesn't even catch it. Like, it doesn't even know. It's just like, whatever, blah, blah. Memory's just like doing weird stuff. Alright, so I have 6 vertices times float. What's wrong with this? It's at the right location. It sends it to GPU. Right? Stupid GPU. Draws it. But what's wrong? This is the main problem at all. So we got the XY in here. Not using a projection matrix for testing purposes of initial setup. It splits up the XY and CW. do the stream draw. There's also dynamic draw. Yeah. You can also have certain parts of it be static draw. Just don't change it. Stream draw. Yeah, vertices getting them copied into. Maybe I did it wrong. I'm supposed to mem copy into it. Oh, this is bad. It has more than one definitions of vertices. And it has one of these. This is funny. But what is it not liking? Alright, I'll do this later. I don't have more time right now. 24. Does it do the shader program? Or does it compile a shader program? Maybe say it's setting shader to like nothing. That's the only thing I could think of right now. What does that say? Three. It says something. Is that a valid number? Oh, it creates shader program within text. Thing or text texture. It's actually bad that it does that.